Alright, so welcome back to another episode of Code with Akya. Today we'll be diving into one of the most important algorithms for finding minimum spanning tree of a graph, the MST, minimum spanning tree. So this is called as the Prim's algorithm. So if you're working with weighted connected graphs and just need to find a subgraph that connects all the vertices with minimum possible total weight, then you have to use this algorithm. If you genuinely want to find a subgraph that connects all vertices with minimum possible total weight, then this is the algorithm for you. So let's jump right into it and understand it by definition. So by definition, Prim's algorithm is a greedy algorithm that finds the minimum spanning tree, the MST, for a weighted undirected graph. It starts from the arbitrary vertex and builds the MST by adding the smallest edge that connects a vertex into the tree to the vertex outside of it. So that's basically the definition of what exactly Prim's algorithm is. So let's just now look at the steps of how do we even perform a Prim's algorithm. Start with a single arbitrary vertex and mark it as part of MST. So this is how it works. The second step is find the smallest edge that connects the MST to the vertex which is not yet included. Then the third is add this vertex and edge to MST and then repeat until all vertices are included in the MST. That's how you build a perfect graph. So now that we've understood what exactly is the step-by-step process, let's look at the pseudocode and try to understand what exactly we have to do. So you can just pause the video and look at the pseudocode and understand how we are going to perform each thing. It's going to be pretty simple. Once you look at the pseudocode, once you know the pseudocode, it is too damn easy to just perform the code. So just pause the video and look at the pseudocode and then we'll move on to the coding part. All right, so let's get on to the practicals. So first of all, we import the heap. HEAPQ, that's the heap. Once you're done with importing the heap, we'll now create a function calling it the prim. It will have two basic arguments, graph and start. Then we'll initialize the minimum spanning tree, the MST, as MST, obviously. Then priority queue to place the smallest edge. That's what our pseudocode said. So how do we even do that in coding? So minimum heap, right inside of it 0 to start. So this is going to be basically our cost and node. That's how it's going to work. And then the total cost of MST is going to be our total cost. That is V initially 0, right? Then as per our pseudocode, we have to create a while loop. So inside of the while loop, we'll just simply assign two things, code, node. That's it. And then if node is not visited, then we'll add that particular node to visited list and then count the cost to visit that particular node. And then we'll append the entire stuff into MST, right? So that's what you have to do. So let's just do that real quick. So visited.add node, so that we'll just add the nodes that are visited. Then total cost is equal to plus is equal to cost. And then mst.append is equal to cost and node. We're going to save both of these things. And once done, we'll just check for the adjacent nodes, the neighbors, so that we can also count for them. Right. He push, and then there is the weight, and then there is the neighbor. All right, both are perfectly completed. Now return MST comma total cost. Okay, now the graph. A of now A will have like two childs B and C. B to C, and then A to B, C, D, 2, 3. Shall be something like a 1, maybe. Okay. So mostly the adjacency list is adjacency or adjacency or adjacency or whatever that happens to be. So basically the list is going to be pretty ready. Obviously, then we'll just define a starting vertex, and once we have a starting vertex, we'll just run this entire stuff. Running Prim's algorithm will basically done by the MST and the cost. So the graph and vertexes will be found out of it. And once I find both of those things, I'm good to go for MST and cost both. So see how does that work, and it's perfectly working. As you can see, it's working pretty well. So that was all about the Prim's algorithm for finding the minimum spanning tree. It is simple but powerful approach for slowing network design problems. So if you enjoyed the video, don't forget to like and subscribe. If you didn't enjoy the video, then don't forget to dislike. So if you liked it, just subscribe to Code with Akya for more contents like this. Next time we'll be discussing, let's just say, crook shell algorithm. I think, yeah, crook shell algorithm, another approach to finding the MST. So thanks for watching. See you in the next one.